Look up at the night sky, and what do you see? A scattering of stars, a distant galaxy maybe, and endless blackness between them. But what if I told you that emptiness isn't empty at all? What if the universe is secretly crisscrossed by vast, invisible highways, cosmic tunnels, woven into the very fabric of space itself? Imagine for a moment that these hidden pathways aren't just the universe's dark scaffolding, but something far more extraordinary, a network used by civilizations beyond our wildest dreams. This isn't science fiction. This is the cosmic web, a mysterious structure of dark matter and gas that binds galaxies together like threads in a tapestry. And some scientists believe it could be the ultimate alien superhighway, a shortcut through the cosmos that advanced beings might have already mastered. Think about the way ancient humans built roads across continents, connecting distant lands and cultures. Now, picture a version of that, but on a scale so immense, it defies comprehension. The cosmic web stretches across billions of light years, a labyrinth of filaments and nodes where galaxies cluster like cities at the intersections of invisible freeways. If there are civilizations out there far older and wiser than ours, why wouldn't they use this ready-made infrastructure to traverse the universe? The idea isn't as far-fetched as it sounds. Dark matter, the unseen glue holding the cosmic web together, doesn't just shape the universe. It might also be the key to unlocking its greatest secrets. What we're about to explore isn't just a theory. It's a doorway into one of the most thrilling mysteries in modern astrophysics. Could the cosmic web be more than just a relic of the Big Bang? Could it be a living, breathing network, humming with activity we've yet to detect? From whispers of ancient alien artifacts to mind-bending physics that could make interstellar travel possible, this journey will take us to the edge of what we know and far beyond. So buckle up, because we're not just talking about the universe's hidden architecture. We're talking about the possibility that we're standing at the threshold of discovery, staring at a map we've only just begun to decode. And if we're right, the cosmic web might be the greatest story the universe has ever told. The cosmic web isn't just a backdrop to the universe. It is the universe on the grandest scale imaginable. Picture the delicate threads of a spider's silk, but magnified 1 trillion times over, stretching across billions of light years. These filaments, woven from dark matter and ionized gas, form a colossal skeleton that cradles galaxies like pearls on a string. It's the universe's hidden architecture, a blueprint written in the language of gravity and time. And just like the neural networks in our brains where electrical impulses zip between synapses, the cosmic web hums with activity, channeling matter and energy toward dense nodes where galaxies cluster in dazzling superhighways of light. To grasp just how vast this structure is, consider this. If our Milky Way were the size of a grain of sand, the cosmic web would span the length of 100 football fields. Within its labyrinthine strands, galaxies aren't scattered randomly. They're drawn like moths to flame toward intersections where filaments collide, piling up into glittering megacities of stars. These cosmic hubs, known as galaxy clusters, can contain thousands of galaxies bound together in a gravitational dance, each one a tiny island in an ocean of dark matter. But here's what truly boggles the mind: we can't even see most of this web. Dark matter, the invisible hand sculpting the universe, makes up roughly 85% of its mass. It doesn't emit light or absorb it. It only reveals itself by the way its gravity bends space, tugging galaxies into alignment like puppets on strings. The rest is hot, diffuse gas, so thin it would feel like a vacuum to us, yet dense enough to glow in X-ray telescopes as it snakes between galaxies. This isn't just some static relic of the Big Bang either. The cosmic web is alive with motion, a dynamic highway where gas flows toward galaxy clusters, feeding their growth over billions of years. Some astronomers compare it to a river system, with tributaries funneling matter into ever larger reservoirs. Others see it as the universe's circulatory system, pumping the raw materials for stars and planets across the cosmos. And just like ancient trade routes shaped human civilization, the cosmic web may have shaped life itself. Without these filaments funneling gas into galaxies, stars might never have ignited, planets might never have formed, and we wouldn't be here to ponder the mystery. So when we trace the web's filaments on a supercomputer simulation or glimpse their faint glow in deep space surveys, we're not just mapping the universe, we're reading the story of our own origins, written in the ink of dark matter and starlight. Dark matter is the silent architect of the universe, the unseen force holding the cosmic web together. Without it, galaxies would fly apart like sparks from a bonfire, their stars scattering into the void. Think of it as the invisible scaffolding behind a towering skyscraper. You don't see the steel beams, but without them, the entire structure collapses. That's dark matter's role, an ethereal framework sculpting the cosmos on the grandest scale. Its gravitational pull is so immense that entire galaxies orbit it like planets around a star. Take our own Milky Way. The stars at its outer edges whirl faster than they should, as if tugged by an unseen hand. That hand is dark matter, a vast halo enveloping our galaxy, its gravity keeping everything in place. But here's the twist: we've never directly observed it. Dark matter doesn't interact with light. It doesn't glow, reflect, or absorb. It's a ghost, detectable only by the way it warps space itself, bending light from distant galaxies like a cosmic funhouse mirror. So what is it made of? Scientists have two leading candidates, WIMP and axions. WIMP, weakly interacting massive particles, are hypothetical heavyweights, lumbering through space like celestial boulders, barely nudging ordinary matter. Axions, on the other hand, are featherlight, flitting through the universe like a whisper. Both could explain dark matter's grip on galaxies, but after decades of hunting, we've found neither. Underground labs, shielded from cosmic noise, listen for WIMPs' faint bumps. Telescopes scan the heavens for axions decaying into light, yet the mystery endures. This isn't just a gap in our knowledge, it's a crack in reality's foundation. Imagine if 85% of everything in your house was invisible. You'd stub your toe on chairs you couldn't see, feel drafts from unseen windows. That's our universe. Dark matter's gravity shapes everything, from the tiniest dwarf galaxy to the largest supercluster, yet it slips through our fingers like smoke. Some theorists even wonder if we've got it all wrong, if dark matter isn't a particle at all, but a flaw in Einstein's equations. Assign gravity works differently on cosmic scales. One thing's certain, without dark matter, the cosmic web wouldn't exist. Those filaments threading the universe, they're rivers of dark matter, flowing toward gravitational valleys where galaxies bloom like flowers in a meadow. It's a reminder that the universe is far stranger than we've dared to dream, a place where the most powerful forces are the ones we can't see. And if we ever crack its code, we might not just solve a scientific puzzle, we might unlock the universe's greatest shortcut. At the heart of the cosmic web, where dark matter filaments twist and collide, galaxies gather like commuters in a grand central station. These intersections, cosmic metropolises teeming with stars, are where the universe's most dramatic events unfold. Picture New York City at rush hour, but instead of taxis and pedestrians, imagine hundreds of galaxies swirling in a gravitational waltz, each one a glowing island of billions of stars. The energy here is staggering. Gas piles up in these crowded hubs, compressed by the sheer weight of surrounding matter until it ignites, sparking bursts of new stars at rates dwarfing anything in our quiet corner of the Milky Way. These galaxy clusters aren't just dazzling spectacles, they're factories of creation. The same forces that jam-pack them with galaxies also superheat the gas between them to millions of degrees, causing it to glow in X-rays like a celestial neon sign. Within this seething cauldron, black holes grow to monstrous sizes, feasting on the chaos around them while blasting jets of energy across the void. It's a place of extremes, where gravity and radiation dance on a knife's edge. And if life exists beyond Earth, these frenetic hubs might just be where it thrives most. Consider the logic. More stars mean more planets. More planets increase the odds of habitable worlds. And in the dense core of a galaxy cluster, where stellar neighborhoods are packed tight, the chances of civilizations crossing paths skyrocket. Imagine an advanced species born in such a place, surrounded by countless neighboring stars, with resources and potential allies just a short interstellar hop away. Their cosmic skyline wouldn't be a scattering of faint dots like ours, but a blazing tapestry of nearby suns, some perhaps hosting fellow travelers in the great galactic conversation. But it's not just about proximity. The very conditions that make these hubs so vibrant, intense radiation, gravitational tugs from passing galaxies, even the occasional collision of entire star systems, could also drive evolution at an accelerated pace. Harsh environments breed resilience. On Earth, life thrives in boiling hydrothermal vents and frozen tundras. Who's to say cosmic metropolises couldn't foster beings adapted to their own extreme surroundings? Yet there's a paradox. While these hubs pulse with energy, they're also tombs. Over billions of years, galaxies in clusters merge and cannibalize one another, their stars either flung into the void or swallowed by the supermassive black holes at their centers. It's a reminder that even the universe's grandest cities have lifespans, but while they last, they shine beacons in the dark, drawing in matter, energy, and perhaps even intelligence from across the cosmic web. So if the cosmic web is the universe's hidden infrastructure, could advanced civilizations be using it as a shortcut through the cosmos? The answer might lie in the filaments themselves, those vast, winding threads of dark matter and gas stretching between galaxies. To an interstellar traveler, these filaments could be more than just cosmic scaffolding. They might be the ultimate express lanes, offering a way to cross unimaginable distances with less energy than it would take to blaze a trail through empty space. Here's why: space isn't uniformly empty. Most of it is a near-perfect vacuum, but filaments are different. While their gas is still incredibly sparse, just a few atoms per cubic meter, they're denser than the voids surrounding them. That slight difference could be crucial. Imagine you're driving across a desert. The quickest route isn't just a straight line, it's the one that passes by the rare gas stations. In the cosmic web, filaments might serve as those pit stops, offering traces of hydrogen and dark matter that could be harvested or used for gravitational slingshots. The physics gets even more intriguing when you consider how objects move through these filaments. Dark matter's gravity creates a natural, downhill slope toward the denser nodes, meaning a ship could ride these gravitational currents like a surfer catching a wave. Advanced civilizations might not even need conventional propulsion. Instead, they could harness the filament's pull, letting the universe itself do the heavy lifting. Some theories even suggest that manipulating dark matter's peculiar properties could allow for shortcuts in spacetime, turning a billion light-year journey into something far more manageable. But the real advantage, energy efficiency, escaping a galaxy's gravity, takes enormous power, but filaments offer a gentler gradient. A ship could leave its home galaxy along a filament, coasting on minimal thrust until it reaches a hub, then hop to another filament toward its destination. It's the cosmic equivalent of taking the interstate instead of bushwhacking through uncharted wilderness. Could this explain why we haven't found aliens yet? If civilizations are using filaments as highways, they'd naturally converge on the busiest intersections, places like galaxy clusters, not quiet backwaters like the Milky Way. It's a humbling thought. We might not just be late to the party, we might be living in the cosmic countryside, far from the interstellar trade routes humming with activity. The universe's greatest thoroughfares could be right in front of us, woven into the dark, waiting to be explored. If a civilization advanced enough to harness the cosmic web existed, how might they use it? Picture a society billions of years ahead of us, no longer bound to planets or stars, but operating on the scale of entire galaxies. These hypothetical beings, often called Type 3 civilizations, wouldn't just live within the universe. They'd reshape it, and the cosmic web would be their ultimate tool. One possibility, energy harvesting on a mind-bending scale. We've imagined Dyson spheres megastructures enclosing stars to capture their power, but a Type 3 civilization might think bigger. Instead of a single star, they could tap into the vast rivers of hot gas flowing through cosmic filaments. These currents, though diffuse, stretch across millions of light years, carrying enough energy to fuel unimaginable projects. Imagine colossal magnetic fields stretched along filaments, siphoning energy from the charged particles whizzing through them. Or dark matter itself, untouched and unseen, could be converted into a power source through physics we've yet to discover. Communication would be another frontier, with galaxies separated by unimaginable voids, sending signals the traditional way, with light or radio waves, would mean waiting millions of years for a reply. But the cosmic web might offer a shortcut. Quantum entanglement, the bizarre phenomenon where particles remain connected across any distance, could be amplified on a cosmic scale. If dark matter or the web's structure somehow facilitates entanglement, civilizations could use it to send instantaneous messages between distant nodes. The filaments themselves might act as giant fiber optic cables, transmitting information encoded in gravitational waves or dark matter vibrations. Then there's the web's sheer structure, a ready-made transit network. A Type 3 civilization might not need starships in the traditional sense. If they've mastered spacetime manipulation, they could treat cosmic filaments like subway tunnels, warping space within them to create stable wormholes. The immense gravitational pull of filaments could serve as natural accelerators, flinging objects toward distant galaxy clusters without the need for fuel. But the most intriguing idea, the cosmic web might not just be a tool, it could be a product. Some theories suggest advanced civilizations could engineer the universe's large-scale structure to optimize growth, communication, or even computation. Dark matter might not just be a relic of the Big Bang, it could be a manipulated substrate, fine-tuned by intelligence beyond our comprehension. We look up and see a natural web, but it might be something far stranger, the universe's greatest infrastructure project, billions of years in the making. Whether any of this is happening now is impossible to say, but the cosmic web's existence raises a haunting question. If civilizations can reach this level of mastery, why haven't we found traces of them? Perhaps they're hidden in plain sight, their work so vast, we mistake them for nature itself. The line between universe and engineering might be thinner than we think. The Fermi paradox has haunted astronomers for decades. If the universe is so vast and ancient, why haven't we found any signs of intelligent life? But what if we've been looking in the wrong places? The cosmic web offers a radical solution to this mystery. Advanced civilizations might not be scattered randomly across the cosmos. Instead, they could be clustered along these dark matter highways, hidden in plain sight. Think of it like this. If you were searching for cities on Earth, you wouldn't focus on the middle of the ocean. You'd look along coastlines, rivers, and trade routes where resources and travel converge. The cosmic web works the same way. Filaments are the universe's natural transit corridors, dense with gas, dark matter, and the gravitational pull needed for efficient travel. Alien civilizations, if they exist, wouldn't waste energy crossing empty voids. They'd follow the cosmic web's paths, congregating near galaxy clusters or within filaments themselves, places our telescopes rarely scrutinize. This could explain our eerie silence. Our Milky Way sits in a galactic backwater, a quiet suburb far from the crowded superhighways where cosmic traffic would be heaviest. If most advanced life is clustered along filaments, their signals, whether radio waves, laser pulses, or even engineering projects on a galactic scale, might never reach us. We're the isolated village, unaware of the bustling cities hidden beyond the horizon. There's another possibility. They're not just hiding, they're invisible by design. The cosmic web's filaments are saturated with dark matter, a substance that doesn't interact with light. What if an ancient civilization discovered how to harness it, not just for travel, but for stealth? Imagine bending dark matter like a cloak, rendering entire megastructures undetectable to our instruments. To them, we might be the primitive outliers, unworthy of contact. Or perhaps they don't need planets at all. A truly advanced species might abandon physical forms, uploading consciousness into vast computational networks woven into the cosmic web itself. Their cities could be data streams flowing along dark matter currents, entirely imperceptible to our eyes. The Fermi paradox assumes aliens would colonize the galaxy like we would, spreading outward in all directions. But the cosmic web suggests a different model, civilizations expanding along the filaments, leaving empty voids untouched. If that's true, then the answer to "where is everyone?" isn't that they're absent, it's that we're standing in the cosmic countryside, shouting into the dark, while the real conversation is happening light years away, along the universe's hidden freeways. Dark energy is the universe's silent disruptor, an invisible force stretching the cosmos apart at an ever-increasing pace. While dark matter weaves the cosmic web together, dark energy threatens to unravel it. Picture a vast highway system where the roads themselves are slowly widening, pushing destinations farther apart even as travelers race to reach them. That's the cosmic web under dark energy's grip, filaments stretching thinner, galaxy clusters drifting toward isolation, and the universe's great connective threads straining under the pressure of expansion. But what if this isn't just a slow-motion demolition? What if advanced civilizations have learned to ride this wave? Dark energy's relentless push could be more than a cosmic annoyance. It might be the ultimate tool for manipulating spacetime. Imagine a species so advanced they don't fight the expansion, they harness it. Just as sailors use wind to cross oceans, these beings could exploit dark energy's repulsive force to slingshot between galaxies, turning the universe's accelerating sprawl into their own hyperlane. The mechanics are mind-bending. Dark energy operates on the fabric of spacetime itself, creating more space between galaxies with every passing moment. For a civilization mastering this force, the implications are staggering. They could create localized expansion fields stretching space behind a spacecraft while compressing it ahead, effectively surfing the cosmic tide. No fuel needed, no engines, just the universe's own expansion as their propulsion system. Yet there's a darker possibility. As dark energy accelerates the universe's expansion, distant galaxy clusters will eventually vanish beyond an unreachable horizon, their light stretched into oblivion. The cosmic web's grand highways could become desolate, cutting off entire regions of the cosmos from one another. This isn't science fiction, it's the fate awaiting our universe billions of years from now. Advanced civilizations racing against this cosmic deadline might be the reason we detect no signals. They could be funneling all resources into escaping their local cluster before space itself strands them in an island universe. Here's the twist: dark energy's grip isn't uniform. Some theories suggest it could fluctuate, creating pockets where expansion slows or reverses. A sufficiently advanced species might identify or engineer these regions, crafting oases of stability in an otherwise runaway cosmos. The cosmic web wouldn't just be their highway, it could become their lifeline, with dark energy's ebb and flow manipulated like a cosmic throttle. Whether dark energy is a destructive force or the ultimate propulsion system depends on perspective. To us, it's a puzzle wrapped in equations. To a civilization older than stars, it might be the key to the universe. One thing's certain: the fate of the cosmic web, and any life within it, hangs in the balance between dark energy's push and the ingenuity of those who dare to ride it. The universe holds a secret stash of fuel, one we've been overlooking for decades. Scientists call it the missing baryon problem. Baryons are the building blocks of ordinary matter, protons and neutrons that make up everything from stars to smartphones. But here's the catch. When astronomers tally up all the baryons they should see based on the universe's structure, nearly half are unaccounted for. It's like checking your bank statement and realizing half your money's vanished. So where is it? The answer might lie in the cosmic web's filaments, not as dark matter, but as ionized gas, superheated and stretched so thin it's nearly invisible to our telescopes. This isn't just a cosmic accounting error. That missing matter could be the universe's best-kept fuel reserve. Picture a highway dotted with hidden gas stations, their signs too faint to read from a distance. For an advanced civilization, these wispy rivers of ionized gas, oxygen, hydrogen, and other elements stripped of their electrons might be the perfect pit stops. Unlike dark matter, which refuses to interact with ordinary matter, this plasma could be harvested, funneled into engines, or even used to create propulsion beams. The physics is tantalizing. Ionized gas conducts electricity, responds to magnetic fields, and could theoretically be manipulated into a propulsive force. Think of it like sailing. Ships on Earth harness the wind, but interstellar travelers might ride the cosmic web's charged currents. A spacecraft could deploy electromagnetic sails, catching the faint push of ionized particles flowing through filaments, no fuel tanks required. The energy needed would be immense by our standards, but for a civilization mastering fusion or antimatter, it's just another day in the cosmos. Some theories even suggest advanced beings might seed filaments with extra ions, turning these natural pathways into turbocharged intergalactic thoroughfares. But here's the twist. This missing matter isn't just floating passively. Filaments act as cosmic aqueducts, channeling gas toward galaxy clusters in a slow, gravitational current. Over billions of years, these currents feed star formation, rebuild planets, and potentially refuel passing travelers. If aliens are out there, they're not just hitching rides on the web, they might be tapping into its veins, siphoning the universe's hidden fuel to power journeys we can barely imagine. The implications are staggering. If even a fraction of the missing baryons are locked in filaments, the cosmic web isn't just a map. It's a gas station, a charging port, and a navigation system rolled into one. We've been searching for alien megastructures, Dyson spheres, ringworlds, but the real signature of an advanced civilization might be subtler: traces of ionized gas, inexplicably redirected or depleted along the web's strands. So next time you hear about the universe's missing matter, don't think of it as lost. Think of it as reserved, waiting for someone or something to claim it. The cosmic web's filaments may hold more than the secrets of the universe's structure. They could be the key to unlocking its greatest journeys. Fast radio bursts are one of the universe's most baffling mysteries. Brief, intense blasts of radio waves that flare up for mere milliseconds, then vanish without a trace. First discovered in 2007, these cosmic flashes pack more energy than our Sun emits in 80 years, yet they last shorter than the blink of an eye. What could possibly generate such violent, fleeting signals? The leading theories range from cataclysmic neutron star collisions to the violent deaths of black holes. But there's another, far more tantalizing possibility. What if these bursts aren't natural at all? What if they're deliberate signals, alien beacons, pulsing along the cosmic web's filaments, guiding travelers across the universe? The timing fits. Fast radio bursts often originate in regions where cosmic filaments intersect, those dense highways of dark matter and gas we've been exploring. Think of them as lighthouses along a shoreline. They're brief but brilliant flashes cutting through the dark, marking safe passages or signaling points of interest. For a civilization navigating the cosmic web, such pulses would be ideal, energetic enough to pierce through dust and gas, yet fleeting enough to avoid drawing too much attention. The bursts' erratic patterns could even be intentional, a way to distinguish artificial signals from natural noise. Here's where it gets even stranger. Some fast radio bursts repeat, firing off at irregular intervals unlike anything seen in stellar explosions. One particularly famous repeater, known as FRB 12-1102, follows a rough but detectable cycle, active for about 90 days, then silent for 67. That's not random. That's the kind of pattern you'd expect from a system with purpose, perhaps a rotating beacon or a powered transmitter cycling on and off. Could these bursts be messages? Maybe, but they might serve an even more practical function. Imagine you're piloting a ship through the cosmic web's tangled filaments. Navigating by starlight would be hopeless. Galaxies drift, stars fade, but a network of synchronized radio bursts, each timed and positioned with precision, could act as cosmic mile markers, helping travelers triangulate their position across billions of light years. The bursts' extreme brightness would make them visible from staggering distances, while their millisecond duration keeps energy use efficient. It's the universe's ultimate GPS, built into the fabric of space itself. Of course, not all fast radio bursts need to be artificial. nature is more than capable of producing its own spectacular fireworks, but the overlap between their origins and the cosmic web's structure is too intriguing to ignore. If advanced civilizations exist, especially those using the web as a transit network, it stands to reason they'd exploit its natural pathways for communication. Perhaps these bursts are unintended leakage from their technology, like our own radio broadcasts drifting into space, or maybe there's something far more deliberate, a way to say, we're here. The next time a fast radio burst flickers across the cosmos, remember, we might not just be witnessing a natural wonder. We could be glimpsing the shadow of something far greater, a universe humming with intelligence, its hidden highways alive with signals we're only beginning to decode. Quantum entanglement is one of the most bizarre and fascinating phenomena in physics, a connection so profound that two particles can become intrinsically linked, no matter how far apart they drift in the cosmos. Change the state of one, and its partner instantaneously responds, even if separated by billions of light years. It's as if the universe maintains invisible threads between them, weaving a hidden communication network that defies the speed of light. Now, imagine a civilization advanced enough to harness this phenomenon, turning quantum entanglement into their interstellar internet. No lag, no waiting. Just instantaneous messaging across the vast expanse of the cosmic web. This isn't just theoretical speculation. Quantum entanglement has been experimentally proven, with particles coordinating their behavior faster than light could travel between them. Einstein famously called it spooky action at a distance, dismissing it as impossible. Yet, here we are, with lab experiments confirming it's very real. The question isn't whether entanglement works, it's whether something out there is already using it. Consider this. UFO reports often describe craft moving in perfect unison, executing maneuvers that would require split-second coordination. If these objects aren't locally controlled but instead linked via quantum entanglement, their synchronized movements suddenly make sense. No radio signals zipping back and forth at light speed, just an instantaneous, unbreakable connection, allowing fleets of ships to pivot, accelerate, or vanish as one. It's the ultimate command and control system, operating on a level beyond our current grasp. The implications are staggering. If civilizations embedded in the cosmic web have mastered entanglement-based communication, their networks would be invisible to us. No radio chatter, no detectable signals, just silent, instantaneous coordination woven into the fabric of reality itself. This could explain why our search for extraterrestrial intelligence has come up empty. We've been listening for radio waves, while they're whispering through quantum links we're only beginning to understand. But here's the twist. Entanglement alone doesn't transmit information in the traditional sense. You can't send a message by manually tweaking one particle. The randomness of quantum states prevents it. Yet, advanced physics hints at workarounds. Some theories suggest entangled particles could be pre-programmed like cosmic Morse code, their correlations arranged in advance to convey meaning. Others propose that manipulating spacetime itself, perhaps through the cosmic web's dark matter scaffolding, could turn entanglement into a controllable channel. For a civilization that's cracked this code, the cosmic web wouldn't just be a transit network. It would be a living, breathing nervous system, with entangled nodes humming in unison across galaxies. And if they've left any traces, we might find them not in radio telescopes, but in the subtlest quantum anomalies, patterns in the noise that hint at something far more deliberate than randomness. The universe is stranger than we've dared to imagine, And if quantum entanglement is the missing piece of the cosmic communication puzzle, then the truth might not be out there in the void. It could be threaded through the very fabric of space, waiting for us to decipher its spooky, silent language. Reports of unidentified aerial phenomena have poured in for decades, blurred lights darting across the sky, crafts maneuvering in ways that defy physics, objects vanishing in the blink of an eye. But what if these sightings aren't random? What if they're glimpses of something far grander, advanced civilizations navigating the cosmic web's hidden highways? Consider the patterns. Some of the most intense UAP activity clusters near regions where cosmic filaments converge, areas rich in dark matter and threaded with ionized gas. Take the infamous Phoenix Lights incident in 1997, where thousands witnessed a mile-wide V-shaped object drifting silently over Arizona. The event occurred along a celestial longitude that, when mapped onto the large-scale structure of the universe, aligns with a minor filament stretching toward the Virgo cluster, a superhighway of galaxies just 54 million light-years away. Coincidence? Maybe, but when similar sightings appear near other filament galaxy intersections, the odds start feeling thinner. Physics offers a compelling explanation. If an advanced species has mastered travel along the cosmic web, they wouldn't brute force their way through empty space. Instead, they'd ride the gravitational currents of filaments, using them as cosmic slipstreams to minimize energy expenditure. The sudden accelerations and right-angle turns reported in UFO encounters, those could be artifacts of spacecraft transitioning between filaments, exiting one gravitational flow and latching onto another, like a subway car switching tracks. The eerie silence often described by witnesses fits too. In the near vacuum of these filaments, propulsion wouldn't rely on noisy combustion, but on manipulating spacetime itself. Then there's the lighting. Many UAPs glow with an uncanny luminescence, often shifting colors unpredictably. This matches the behavior of ionized gas in filaments, where charged particles emit light when excited. A vessel harvesting or interacting with this plasma might naturally radiate similar hues. Even the erratic movements, jerky stops, instantaneous reversals mirror how objects would behave in the turbulent eddies of dark matter flows, where gravity isn't uniform but clumpy and dynamic. But the most provocative evidence lies in timing. Some UAP hotspots experience waves of activity coinciding with astronomical events, like a filament being lit up by a passing quasar or a nearby supernova. It's as if these events act as cosmic toll booths, triggering surges in traffic along the web. The Hestalan lights in Norway, for instance, flare with eerie regularity during periods of heightened solar wind, which could theoretically energize the local filament's gas, making it more navigable. Critics argue that attributing UFOs to cosmic web travel is speculative, and they're right. Yet the alternative, that all these sightings are misidentifications or hoaxes, feels equally unsatisfying when patterns persist across decades and continents. Perhaps the truth lies somewhere in the interplay. The cosmic web might not just be a hidden superhighway for aliens. It could be the reason we only catch fleeting glimpses, because what we're seeing aren't ships lingering in our skies, but vessels briefly docking at a galactic rest stop before slipping back into the dark currents of the universe. So next time you hear about a cluster of UFO sightings, don't just look at the sky, look at the map of the cosmos. The answers might not be floating in our atmosphere. They could be written in the invisible threads stitching the universe together. And if we follow those threads, we might not just solve the UFO mystery. We might find the on-ramp to the greatest journey humanity could ever take, across cultures and millennia, our ancestors told stories of shimmering bridges stretching across the heavens, paths linking the realm of mortals to the divine. The Norse spoke of Bifrost, a burning rainbow road guarded by the god Heimdall. Indigenous Australians shared tales of the Milky Way as a celestial river walked by creation spirits. Chinese legends described the Silver River, where star-crossed lovers met once a year on a bridge of magpies. These myths seem like poetic fancy until you line them up with modern astrophysics. Could these stories be humanity's earliest intuition of the cosmic web? It's uncanny how many ancient sky myths mirror the web's structure. Take the Norse Bifrost, often depicted not as a simple arch, but as a vibrating, multicolored filament connecting worlds. The prose Edda describes it as the strongest of all bridges, yet so fragile it would shatter when the giants marched across it at Ragnarök. That duality, strength and fragility, eerily echoes cosmic filaments. On one hand, these dark matter threads are the universe's backbone, holding galaxies together across billions of light years. On the other, they're ghostly wisps, their gas so diffuse a spaceship could fly through one without noticing. Even the visual symbolism aligns. Indigenous cultures from the Americas to Siberia portrayed the Milky Way as a pathway of souls or road of spirits, a glowing trail through the dark where ancestors traveled. Modern telescopes reveal our galaxy isn't floating in isolation. It's embedded in the Laniakea supercluster, a sprawling network of filaments that indeed resembles a celestial highway. The Kalahari Bushman's myth of the Great Sky Road, said to pulse with the energy of creation, takes on new meaning when you learn filaments funnel gas into galaxies, birthing stars even now. But how could ancient people, lacking telescopes or astrophysics, grasp such a concept? The answer might lie in humanity's oldest science, pattern recognition. Our brains are wired to seek connections. It's why we see faces in clouds or animals in constellations. When early stargazers observed the Milky Way's band of light, their minds may have subconsciously mapped it onto familiar structures, rivers, roads, bridges. And in doing so, they accidentally sketched the cosmic web's silhouette. The most compelling parallel comes from Hindu cosmology. The Rigveda describes a golden womb called Hiranyagarbha, from which threads of creation radiate outward, binding the cosmos together. Modern simulations of the cosmic web show an almost identical structure, filaments branching from dense nodes like threads from a spindle. The Maya took it further, depicting the world tree Waka-chan as a shimmering axis with roots in the underworld and branches cradling the stars, a vertical twin to the web's horizontal filaments. This isn't just coincidence. Recent studies in neurotheology suggest that certain altered states induced by rituals, fasting, or plant medicines can trigger visions of lattice-like structures strikingly similar to the cosmic web. Participants across cultures report seeing webs of light, interconnected tunnels, or ladders to the stars. Whether these experiences tap into some collective unconscious or simply reflect the brain's hardwired preference for fractal patterns, the overlap is provocative. Perhaps early shamans and storytellers weren't just imagining. Perhaps they were glimpsing through intuition, trance, or sheer cosmic luck the universe's hidden architecture. The Bifrost wasn't just a myth, it was a premonition. What if the cosmic web isn't just a structure, but a program, that twisting network of dark matter filaments, galaxies, and voids might not be natural at all? It could be the glowing circuitry of an unfathomable supercomputer, running our universe like a hyper-advanced simulation. The idea isn't just wild speculation. When scientists map the web's intricate branching patterns, they notice something unsettling. It looks eerily similar to how complex computer networks organize data. Nodes connected by pathways, information flowing along optimized routes. Even the way galaxies cluster at filament intersections mirrors how servers group in a data center for maximum efficiency. Take the observable universe's scale as evidence. The cosmos operates on unfathomably precise mathematical constants, numbers like pi or the speed of light that seem fine-tuned just right for matter and life to exist. Tweak them slightly, and stars wouldn't ignite, atoms wouldn't bond, and reality, as we know it, would crumble. Simulation theorists argue this isn't luck. It's design. The cosmic web's filaments could be the universe's wiring, with galaxies as processing units humming along them, executing some grand calculation we're too primitive to comprehend. Here's where it gets chilling. Some versions of simulation theory propose that advanced civilizations, whether our future descendants or alien architects, built this reality as a cosmic experiment. If true, the web's filaments might not just be transportation routes for hypothetical aliens. They could be the literal code those beings used to manipulate the simulation from outside it. Think of dark matter as the program's hidden variables, unseen but governing everything. The way galaxies move, subroutines executing, fast radio bursts, system pings checking on processes, even quantum entanglements, spooky linked particles fit. They're the equivalent of shared memory addresses between distant parts of the simulation. A striking clue comes from quantum physics itself. At the smallest scales, reality behaves less like smooth, continuous space and more like discrete pixels, tiny packets of energy that jump between states without passing through intermediate points, as if rendered frame by frame. Cosmologists debate whether spacetime might be fundamentally pixelated too, with the cosmic web acting as the mesh connecting these voxels of simulated space. But the most provocative evidence isn't in the stars, it's in glitches, strange cosmic anomalies like particles behaving differently when observed or measurements that change based on expectation. Mirror how video games optimize processing power by only rendering what players directly see. Even déjà vu or Mandela effects could theoretically be artifacts of the simulation, buffering delays, or memory overlaps in a vast computational system. Of course, skeptics counter that patterns don't equal purpose. The universe appears mathematical because math is how we describe it, not necessarily how it was built. Yet the persistence of these parallels keeps the debate alive. If we are living in a simulation, the architects might have embedded clues in the cosmic web's very structure, waiting for a civilization smart enough to recognize the patterns. So are we players, prisoners, or mere lines of code? The answer might lie in the dark threads stitching reality together. Whether the cosmic web is nature's masterpiece or something far stranger, one truth remains: its mysteries are far from solved. And if we ever crack them, we might not just understand the universe, we might discover who's running it. Stretching near a cosmic filament wouldn't just warp space, it could twist time itself. Einstein's theory of relativity tells us gravity doesn't just bend light, it slows clocks. The stronger the gravitational pull, the more time drags. Now picture a spacecraft skimming the edge of a dark matter filament, where gravity's grip is exponentially stronger than in empty voids. For the crew inside, hours might pass while centuries flicker by elsewhere. This isn't science fiction. It's the stark reality of time dilation, and for civilizations riding the cosmic web, it could be the ultimate loophole in interstellar travel. The math is startling. Near a massive galaxy cluster where filaments converge, time can slow by fractions of a second per year compared to Earth, but scale that up to a journey along a filament stretching millions of light years, and the effect magnifies. A voyage that might take millennia from an outsider's perspective could feel like mere decades aboard a ship surfing that gravitational gradient. Suddenly, crossing the cosmos becomes biologically plausible. Crews wouldn't need generation ships or suspended animation. They'd simply let relativity do the work, arriving at their destination younger than the civilizations they left behind. But here's where it gets stranger. Time dilation near filaments might not just be a side effect, it could be engineered. Advanced beings could plot courses to maximize gravitational time warps, essentially using the cosmic web as a temporal slingshot. Imagine a civilization that's mastered this. Their explorers depart along a filament, spend subjective decades charting distant galaxies, and return to a homeworld that's aged only slightly more. To them, the universe's vast timescales would feel compressed, like flipping through chapters of a history book while living in the margins. There's a haunting implication. If aliens are truly leveraging this, we might not just be isolated in space, we could be out of sync in time. A species riding the web's filaments could be thriving in what's our distant future or past, their presence flickering at the edges of our perception like shadows from another epoch. Those eerie UFO sightings that vanish without a trace, they might not be dodging detection, they could be literally slipping between ticks of our cosmic clock. Yet the web's time-bending properties raise ethical dilemmas. Would a civilization that masters temporal dilation become unmoored from the rest of the universe, watching empires rise and fall like mayflies? Or would they use this power to shepherd younger species, intervening across epochs like invisible gods? The cosmic web doesn't just connect places, it might bridge times, and those who learn to navigate its currents could hold the keys to eternity. At the heart of most galaxies, including our own Milky Way, lurks a monster, a supermassive black hole with gravitational power so immense it warps the fabric of reality itself. These cosmic behemoths aren't just destructive forces, they might be the ultimate transit hubs of the cosmic web, natural wormholes where filaments converge and spacetime folds into shortcuts across the universe. Picture a black hole not as a one-way trap, but as a whirlpool in the cosmic ocean, its event horizon the point where the current becomes irresistible, dragging travelers not toward annihilation, but toward unseen destinations along the web's tangled threads. The physics is astonishing yet plausible. Einstein's equations allow for rotating black holes to twist spacetime so severely they create tunnels, Einstein-Rosen bridges, linking distant regions of the universe. While naturally occurring wormholes are theoretically unstable, a supermassive black hole anchored within the dense node of a cosmic filament might be different. The filament's dark matter and ionized gas could act like cosmic reinforcement rods, stabilizing the wormhole long enough for passage. It's the universe's version of threading a needle. Matter and energy entering the black hole could be funneled along the filament's gravitational field lines, emerging light years away near another node. Astronomers already see hints of this. Some active galaxies spew jets of plasma at near light speed, perfectly aligned with the cosmic filament they're embedded in. These aren't random explosions, they're precision beams, as if something inside the black hole is directing energy along the filament like a cosmic guidance system. Even stranger, certain quasars flicker in sync with others billions of light years apart, as if connected by an invisible tunnel, coincidence, or evidence of a network we're only beginning to map. Advanced civilizations wouldn't need to build stargates. They'd co-opt existing ones. A species mastering black hole travel could use them as slingshots, diving toward the event horizon just enough to harness its space-time warp before veering away along a filament's current. The energy savings would be staggering. No fuel needed, just the universe's own gravity as a propulsion system. Some theoretical models even suggest that exotic matter, a substance with negative energy, could be harvested from filaments to stabilize wormholes artificially, turning supermassive black holes into on-demand portals. But the most mind-bending possibility, these black hole junctions might not just span space, they could bridge time. Near a spinning singularity, time slows to a crawl. A traveler skirting the edge could emerge centuries or millennia into the future relative to their point of origin. The cosmic web wouldn't just be a highway system, it would be a time machine, with black holes as its control points. Whether natural phenomena or engineered infrastructure, one thing is clear. The universe has built its own version of interstellar subway stations, and if we're brave enough to look closer, we might find they've been in use long before we dreamed of stars. The universe's hidden highways might demand an equally exotic fuel, matter that defies everything we know about physics. Imagine a substance with negative mass, tugging space outward instead of inward, or dark photons slipping unseen between dimensions. These aren't just sci-fi tropes, they're legitimate theoretical constructs that could unlock the cosmic web's full potential as a traversable superhighway. To navigate filaments without disintegrating in the turbulence of space-time, a civilization would need materials far stranger than anything in our periodic table. Take negative mass. Unlike ordinary matter, which attracts via gravity, negative mass would repel, creating a stabilizing counterforce to a black hole's crushing pull or a wormhole's inherent instability. Picture it like cosmic anti-glue, holding open a tunnel through spacetime that would otherwise snap shut. The math is startlingly sound. Einstein's equations allow for such matter, and recent experiments with quantum fluids have glimpsed analogs of negative mass in lab settings. If harvested from the cosmic web's deepest voids or synthesized in advanced reactors, this exotic matter could turn filaments into stable transit corridors. Then there's dark photons, hypothetical particles acting as force carriers for dark matter, transmitting interactions we've never directly observed. If dark matter truly sculpts the cosmic web, its invisible counterpart to light might be the key to manipulating it. A ship emitting dark photons could theoretically illuminate filaments, mapping their contours in real time or even exciting dark matter into a manipulable state. Some models suggest dark photons could induce localized spacetime warps, bending filaments into tighter curves for shorter jumps between nodes. It's the equivalent of paving your own on-ramp onto the universe's interstate. The most mind-bending possibility, quantum vacuum plasma. Empty space isn't truly empty. It's a seething foam of virtual particles flickering in and out of existence. Advanced propulsion concepts like the Alcubierre warp drive aim to compress this quantum foam ahead of a spacecraft while expanding it behind, effectively surfing a bubble of warped spacetime. Now scale that idea to the cosmic web. A vessel equipped with quantum vacuum thrusters might pump the fabric of filaments themselves, creating temporary waves in spacetime to ride between galaxies. The energy requirements are astronomical, but filaments, rich in ionized gas and dark matter currents, could provide the perfect feedstock. Critics argue that exotic matter is purely hypothetical, with no experimental proof it exists naturally. Yet the cosmic web constantly surprises us. Fast radio bursts, dark matter halos, and even the universe's accelerating expansion were once deemed impossible until observation caught up with theory. If exotic matter does lurk in the web's shadows, its signature might be subtle: gravitational anomalies where filaments intersect, or unexplained energy signatures emanating from seemingly empty voids. The implications are profound. A civilization harnessing such materials wouldn't just travel the cosmic web, they'd rewrite its rules. Filaments might not be static threads woven by the Big Bang, but dynamic pathways shaped over eons by intelligence we can't yet comprehend. And if that's true, the greatest infrastructure project in the cosmos might already be complete, hidden in plain sight, woven into the dark between the stars. Humanity stands at the threshold of an extraordinary possibility, one day hitching a ride on the cosmic web's invisible currents to explore the galaxy. While today's rockets struggle to reach Mars, tomorrow's technology might leverage the universe's own infrastructure to vault us between stars. Projects like Breakthrough Starshot offer a glimpse of this future. The audacious plan aims to propel tiny probes to Alpha Centauri using powerful laser beams, achieving speeds a fraction of light's velocity. But even this revolutionary concept pales compared to what the cosmic web could offer. Starshot's probes would still take decades to reach the nearest star, their trajectories limited by conventional physics. The web, however, presents a shortcut woven into spacetime itself. Picture this: instead of fighting gravity, we surf it. Future spacecraft could deploy gossamer thin magnetic sails, catching the faint but relentless pull of dark matter filaments. Like ancient Polynesian navigators reading ocean currents, interstellar travelers might chart courses along these gravitational rivers, letting the universe's hidden tides carry them between galaxies. The energy savings would be staggering. Current propulsion systems require fuel loads that grow exponentially with distance, but riding the web's filaments could reduce that burden, tapping into the cosmos' own momentum. The challenges, of course, are monumental. We'd need materials strong enough to withstand tidal forces near filament intersections, where gravity spikes unpredictably. Navigation would demand precision beyond anything we've achieved, mapping not just stars, but the invisible topography of dark matter. And then there's time. Even with the web's shortcuts, journeys spanning millions of light years might still outlast human lifespans. Unless we crack relativistic travel or master suspended animation, generations could live and die aboard these arcs. Yet the web might hold solutions to these very problems. Its filaments are threaded with ionized gas that could be harvested en route for fuel or life support. The same dark matter bending space around us might be manipulated to create localized time dilation fields, stretching subjective travel time for crews. Some theorists even speculate that the web's structure could be artificially enhanced, its filaments braided by future engineers to create optimal transit lanes. This isn't just about reaching new worlds, it's about evolving into something new altogether. A species that masters cosmic web navigation wouldn't just visit the universe, it would become part of its living architecture, weaving human ambition into the same threads that bind galaxies together. The web may have been here long before us, but its greatest purpose might still lie ahead, waiting for us to grasp it. If we're searching for alien civilizations that once rode the cosmic web's filaments, we shouldn't just look for their ships, we should hunt for their footprints. Hidden within those dark matter threads could be ancient technosignatures, subtle disturbances left behind by advanced travelers. Picture an archaeologist sifting through layers of sediment, but instead of pottery shards, we're scanning the cosmic web for heat anomalies, structured energy patterns, or unnatural radio emissions lingering in the gas between galaxies. Take heat signatures first. Filaments are already bathed in faint X-ray glow from their sparse ionized gas, but an advanced civilization harnessing these pathways might leave behind thermal fingerprints. Perhaps they used enormous energy collectors to siphon power from the filament's currents, creating localized hotspots that defy natural explanations. Or consider the opposite, unusually cold regions where vast structures could have absorbed thermal energy for unknown purposes. The Chandra X-ray Observatory has already mapped temperature variations across filaments. What if some of those irregularities aren't random at all? Then there's the electromagnetic noise. Across Earth, our radio broadcasts and radar systems create a distinctive technological hum that leaks into space. An alien species utilizing the cosmic web might generate similar signatures not as accidental pollution, but as deliberate navigation beacons or communication pulses designed to travel along filament channels. The trick would be distinguishing this structured noise from natural cosmic static. SETI researchers recently proposed searching for statistical outliers in radio data from filament regions, narrowband signals repeating with uncanny precision, or broadband bursts carrying mathematical patterns in their modulation. Perhaps the most tantalizing technosignature would be evidence of large-scale engineering. The cosmic web's filaments are gravitationally stable over billions of years, an ideal foundation for megastructures. Imagine a Dyson-like swarm not around a star, but wrapped around an entire filament, harvesting its dark matter flows and ionized gas. From afar, it might appear as an anomalous dimming where the filament intersects a galaxy cluster, as if something is blocking portions of its natural emissions. Or we might detect gravity lensing effects that suggest invisible, massive objects aligned too perfectly with filament axes to be natural. Some astronomers speculate that dark matter itself could hold clues. If hypothetical WIMP particles occasionally collide and annihilate, they should produce gamma rays, but what if certain filaments show gamma ray patterns that suggest artificial triggering? It's like finding charcoal deposits in an ancient hearth. The materials are natural. Their arrangement tells a story. The Fermi Gamma Ray Space Telescope's maps already show puzzling concentrations along some filaments that resist easy explanation. The hunt wouldn't be easy. Cosmic timescales mean any traces could be billions of years old, diluted by expansion, or buried under layers of subsequent natural activity. A civilization mastering the web might have intentionally minimized their footprint, leaving only the subtlest marks. Yet the very fact that we're beginning to ask these questions changes everything. For the first time in history, we have telescopes sensitive enough and computer models sophisticated enough to potentially spot these cosmic breadcrumbs. The greatest evidence of alien travelers might not be in their arrival, but in the quiet, enduring echoes of their passage through the universe's hidden highways. Somewhere in the depths of space, hidden behind the thick veil of our Milky Way's dust and stars, an invisible force is tugging at our galaxy with the strength of 1,000,000 suns. Astronomers call it the Great Attractor, a gravitational behemoth so powerful it's pulling entire galaxies, including our own, toward it at over 1,000,000 miles per hour. But here's the mystery: we can't see what's doing the pulling. This isn't just a cluster of galaxies or a supermassive black hole. It's something far stranger, lurking at a crossroads of the cosmic web, and its true nature might rewrite our understanding of the universe's hidden highways. Imagine the cosmic web as a sprawling subway system, with filaments as tracks and galaxy clusters as stations. If that's the case, the Great Attractor could be the grand central terminal, a gravitational hub where multiple superhighways converge, funneling matter and perhaps travelers toward a single, unimaginable nexus. Observations reveal it sits near the heart of the Laniakea supercluster, a vast network of over 100,000 galaxies all drifting in the same direction, as if drawn by some cosmic tide. But when telescopes peer toward its location, they find only scattered galaxies, not nearly enough visible mass to account for the titanic pull we're experiencing. So what's hiding there? One possibility is dark matter, lots of it. The Great Attractor might anchor a dense knot in the cosmic web, where invisible filaments twist together into a gravitational vortex far denser than anywhere else nearby. If dark matter can form structures beyond our current models, this could be its ultimate expression, a dark metropolis woven into the fabric of space itself. But there's another, more tantalizing idea. What if the Great Attractor isn't just a natural phenomenon? What if it's a construct, an engineered gravity well designed to serve as a transit hub for civilizations navigating the web? Think of how ancient seafarers used whirlpools and currents to their advantage. A sufficiently advanced species might harness the Great Attractor's pull to slingshot ships across the universe, using its gravity like a cosmic toll booth to redirect vessels along different filaments. The anomaly's location is suspiciously perfect for this role, positioned where several major filaments intersect, making it an ideal stopover point for long-haul travel. Even its obscurity behind the Milky Way's dust could be more than coincidence. If you were building a galactic transit hub, placing it out of plain sight from most of the local universe might be a strategic choice. Then there's the timing. The Great Attractor isn't just pulling us, it's pulling everything in our local universe toward it on a collision course spanning hundreds of millions of years. Coincidence or synchronization? If alien engineers operated on deep time scales, they might have arranged this slow-motion convergence deliberately, herding galaxies toward a central meeting point for reasons beyond our imagination. Perhaps it's a rendezvous site, a resource depot, or even a kind of awakening signal, a gravitational alarm clock set to go off when certain civilizations reach a specific stage of development. Of course, skeptics argue it's just an unusually dense patch of the cosmic web, a fluke of dark matter distribution, but the numbers don't quite add up. The pull is too strong, too focused, and stranger still, recent surveys have detected something even more massive behind the Great Attractor, an unimaginably large structure nicknamed the dipole repeller that seems to be pushing us from the opposite direction. Are these two anomalies locked in a cosmic tug of war, or are they part of some vast, incomprehensible infrastructure, with the Great Attractor as the drain and the repeller as the faucet, regulating the flow of galaxies like water through a pipe? The truth is, we may never know for certain, at least not until our telescopes can pierce the galactic dust hiding the Great Attractor's core. But one thing is clear, this isn't just a curiosity for astronomers. It's a clue. If the cosmic web truly functions as an alien superhighway, then its most mysterious gravitational hub might hold the key to understanding who or what else is out there and where they're going. And by the time we solve its secrets, we might find ourselves not just observers of the cosmic web, but passengers. What if our cosmic web isn't just a local structure, but one thread in an immeasurable tapestry stretching across realities? the filaments connecting galaxies in our universe might branch far beyond what we perceive, threading through higher dimensions and intersecting with parallel worlds. This radical idea emerges from two cutting-edge theories, brainworld cosmology and quantum foam. Both suggest our universe could be a single brain, a membrane-like plane floating in a higher dimensional space, and the cosmic web's filaments might be where these membranes brush against others, creating portals to entirely different realities. Picture the cosmic web as an enormous subway map, with each line representing a filament in our universe. Now imagine countless other maps layered beneath and above it, their routes occasionally overlapping at certain junctions, the stations where you could switch between worlds. The mathematics of string theory actually allows for this scenario. In these models, our four-dimensional spacetime could be embedded within a 10 or 11-dimensional bulk, with other brains hovering mere quantum distances away. The filaments where galaxies cluster might correspond to points where our brain warps closest to another, creating natural bridges across dimensions. Quantum foam adds another mind-bending layer. At the smallest scales, spacetime isn't smooth. It's a seething froth of virtual particles and wormholes blinking in and out of existence. Some physicists propose these fleeting tunnels could stabilize where cosmic filaments intersect, their immense gravitational fields acting like anchors in the quantum chaos. If true, the web's nodes wouldn't just connect galaxies, they might briefly open doorways to universes with different physical constants, alternate histories, or even versions of ourselves making different choices. The implications for interstellar travel grow exponentially stranger. A civilization mastering brain physics could surf the cosmic web not just across space, but between realities. Instead of threading through filaments in our universe alone, they might slip into adjacent brains where distances are compressed or laws of physics allow faster than light travel. The great attractor's mysterious pull, it might be gravity leaking from a neighboring brain where matter is densely concentrated, those repeating fast radio bursts. Perhaps echoes of transdimensional travelers calibrating their passage. Astoundingly, there might already be observational hints. Certain anomalies in the cosmic microwave background, the afterglow of the Big Bang, show unusual cold spots and geometric patterns that resist conventional explanation. Some theorists suggest these could be bruises where our universe has interacted with others through the cosmic web's scaffolding. Similarly, galaxies occasionally spin in unexpected unison across vast distances, as if influenced by forces outside our spacetime. Of course, skeptics argue this veers into untestable speculation, yet the same was once said about black holes and the Big Bang. As our simulations of the cosmic web grow more sophisticated, they reveal structures within filaments that current physics struggles to explain: pockets of unusual matter distribution, gravitational lensing effects that suggest hidden mass concentrations, or energy signatures with no known cosmic source. Perhaps these aren't glitches, but clues. If the cosmic web truly bridges universes, it would explain one of astronomy's most persistent puzzles: why our universe appears so finely tuned for life. The answer might be that we're just one bubble in a froth of realities, and the web's filaments are the tendrils connecting us to an infinity of other possibilities. The greatest journeys may not lie ahead or behind, but sideways, through dimensions we're only beginning to imagine. What if the cosmic web isn't just a structure, but a mind? The filaments connecting galaxies might resemble neurons in a brain more than highways in space. Side by side, images of the universe's large-scale structure and neural networks in biological brains show eerily similar branching patterns. Both systems optimize for efficiency, forming nodes where information or matter clusters most densely. Both exhibit fractal-like repetition across scales. The similarities are so striking that some scientists speculate the universe itself could be a form of conscious entity, with the cosmic web acting as its synaptic network. This isn't mere philosophical musing. The mathematics underpinning both systems align with uncanny precision. Galaxy clusters transmit energy along filaments much like neurons relay electrical impulses. The universe's expansion mirrors how neural networks grow and adapt. Even the timing matches signals traveling between brain cells take milliseconds, while communication across cosmic filaments occurs over millions of years, scaled to each system's relative size. Could this be coincidence, or evidence of an underlying pattern woven into reality at every level? Fringe theories take this further, proposing that advanced civilizations might have transcended physical forms altogether. Instead of building ships to traverse the web, they could have uploaded their consciousness directly into its structure, using dark matter's gravitational currents as pathways for pure thought. Imagine a species so evolved they've become patterns of information riding the filaments, their intelligence distributed across galaxies like data across servers. Their cities wouldn't be physical constructs, but gravitational resonances, subtle ripples in spacetime humming with organized complexity. The implications unsettle our understanding of life itself. If consciousness can exist as a property of spacetime rather than biology, then the cosmic web might be more than a transit system. It could be an ecosystem home to forms of awareness so alien we wouldn't recognize them as life. Their technology might involve bending dark matter filaments into computational circuits, using the universe's own geometry to process information. Their art could be the delicate gravitational lensing patterns we mistake for natural phenomena. Perhaps this explains why we haven't found concrete evidence of extraterrestrial engineering. The most advanced civilizations may not leave physical traces. Instead, their legacy could be woven into the fabric of reality itself, subtle manipulations of the cosmic web's structure, visible only to those who know how to look. When astronomers detect anomalies in filament density or unexpected energy flows between clusters, they might not be glitches in the data. They could be signatures of something far stranger, a universe that isn't just alive, but awake. And watching, humanity stands at a crossroads, one where ambition and caution pull in opposite directions. The cosmic web's filaments offer a tantalizing shortcut to the stars, but should we reach out and grasp them? Interfering with this ancient, galaxy-spanning network isn't just an engineering challenge, it's an ethical minefield. What if our attempts to harness these dark matter highways inadvertently disrupt equilibrium on scales we can't comprehend? Picture a child tugging at a single thread in a vast tapestry, unaware their curiosity might unravel the whole weave. The cosmic web isn't just infrastructure, it's the universe's backbone, and meddling with it could have consequences far beyond our solar system. One chilling possibility: we might not be alone in using these pathways. If advanced civilizations rely on filaments for transit or communication, our clumsy first steps into this domain could be the equivalent of swinging a flashlight in a dark theater, announcing our presence to everyone in the room. History warns us what happens when civilizations collide over resources. European colonization decimated indigenous cultures for gold and land. Now imagine that scenario played out across galaxies, with the cosmic web as the contested territory. A species millions of years ahead of us might view our tinkering with filaments as trespassing, or worse, a threat. The same currents we hope to ride could carry hostile attention straight to our doorstep. Yet there's another layer to this dilemma. The web's filaments might not be inert. Some theories suggest they function as a self-regulating system, with dark matter and gas flows maintaining cosmic balance. If we extract energy or alter their structure, could we accidentally destabilize star formation in distant galaxies, or worse, disrupt whatever unknown mechanisms keep supermassive black holes in check? Astronomers already track how filaments channel gas into galaxy clusters like rivers feeding lakes. Divert those rivers, and you risk turning vibrant galactic hubs into deserts over astronomical timescales. Our reach could exceed our grasp in ways we're not equipped to predict. Then there's the philosophical weight of the question: do we have the right? The cosmic web has existed for over 13 billion years, shaping galaxies long before Earth formed. It's a shared resource spanning the observable universe, not humanity's private playground. If we claim it for our own, what precedent does that set for other civilizations? Ethical frameworks like the Prime Directive from Star Trek argue against interfering with less advanced societies. But what about interfering with the framework of reality itself? The very act of mapping filaments in detail, let alone manipulating them, could be seen as an arrogant overstep, a refusal to acknowledge our place in a cosmos that doesn't revolve around us. Still, the counterargument burns bright. Progress demands risk. Every great leap in human history, fire, electricity, spaceflight, carried potential for catastrophe. Avoiding the cosmic web out of fear would mean resigning ourselves to cosmic isolation. Perhaps the solution lies in proceeding with humility. Before we lay hands on the universe's dark scaffolding, we might establish protocols, monitoring filaments for signs of existing use, limiting interventions to non-destructive studies, or even broadcasting our intentions across the web as a courtesy. If other civilizations are out there, they may respect a species that approaches the cosmic neighborhood with caution rather than conquest. The choice before us echoes far beyond science. It's a test of maturity, a chance to prove we've evolved not just technologically, but ethically. The cosmic web's filaments may hold the keys to humanity's interstellar future, but they also hold a mirror to our intentions. Will we reach for them with open hands or clenched fists? The answer could determine whether we become stewards of the universe's grand design or the architects of our own undoing. The cosmic web isn't just a map of the universe, it's an invitation. Those dark matter filaments threading the void aren't relics of the past. They could be bustling intergalactic freeways, humming with civilizations we've yet to meet. Every unexplained fast radio burst, every anomalous gravitational tug, every flicker of light where none should be, these aren't just cosmic oddities. They might be breadcrumbs scattered along the web's hidden pathways, waiting for us to follow. Consider what's at stake. If even one advanced civilization has cracked the code to navigate these filaments, the implications rewrite humanity's future. Distances that once seemed impassable could become mere waypoints. The loneliness of our cosmic neighborhood might be an illusion, a trick of perspective, like standing in a desert unaware of the cities just beyond the horizon. The web doesn't just connect galaxies, it collapses the tyranny of space and time, offering shortcuts not just across the universe, but possibly through it. Yet for all its promise, the web remains a mirror. How we approach it reveals who we are. Will we barrel forward, driven by curiosity alone, or pause to listen for the whispers of those who may have traveled these roads before us? The choice between reckless haste and patient humility could determine whether we become guests on this cosmic highway or trespassers. Right now, telescopes are mapping the Webb's structure in unprecedented detail. Gravitational wave detectors are tuning into spacetime's subtle tremors. Quantum labs are probing the fabric of reality itself. Each discovery pulls back another layer, revealing how much we still don't know and how much might be possible. So here's the question that lingers like starlight in the dark. The universe's greatest road trip might already be happening. Are we ready to join, not just as passengers, but as participants, students of the cosmos, humbled by its scale, yet daring enough to reach for its secrets? The Webb awaits. All we have to do is step onto the thread. But what if the cosmic web has more than just highways? What if it has truck stops, rest areas where travelers pause between galaxies? Picture this: rogue planets, untethered from any star, drifting in the dark between filaments like abandoned way stations. These nomad worlds could be cosmic oases, rich in resources harvested from the Webb's currents, water ice from colliding comets, metals from ancient supernova, even pockets of dark matter condensed into exotic fuels. Some might still flicker with geothermal heat, their cores warmed by tidal forces as they pass through dense knots in the filaments. Others could bear the scars of past visitors, strange markings, artificial structures, or discarded technology half buried in frozen regolith. The possibilities ignite the imagination. A rogue planet parked along a filament might serve as the ultimate pit stop, a place to refuel, repair, or even exchange information with other travelers. Advanced civilizations could have seeded these worlds with automated outposts, leaving behind libraries of galactic knowledge or navigation beacons tuned to the Webb's gravitational hum. Or perhaps the planets themselves are the travelers, nudged into the Webb's flow by some long-lost engineering, their trajectories too precise to be random. Scientists have already catalogued dozens of rogue planets, dark, lonely worlds detectable only when they briefly warp the light of distant stars. But what if we've missed the most intriguing ones? Planets intentionally camouflaged, their surfaces engineered to blend into the cosmic background, or worlds that aren't worlds at all, but disguised way stations, rest areas masquerading as natural objects. This isn't just speculation. Recent simulations suggest rogue planets could survive for billions of years in interstellar space, their subsurface oceans shielded by thick ice, potentially harboring life. Now imagine stumbling upon one and finding it warm, lit, occupied. Want to explore this wild idea further? In our next video, we'll dive into the evidence and the eerie implications of rogue planets as cosmic truck stops. Could these drifters hold the key to unlocking the Webb's secrets? Or might they be the universe's most unexpected welcome centers? The answer might be closer than we think, floating in the dark, just off the intergalactic highway. Click here to join the hunt. The next stop on our cosmic journey awaits.